Hello. In this video, I'm going to be solving our third example problem for analyzing stress at a point and stress transformation. So here is our problem setup. As you can see, we have our plane stress here with normal, x normal of 15 ksi, normal stress in y is 12 ksi, shear stress is negative 10 ksi, that's because in the right face it's going clockwise. And we have a declining plane here of 48 degrees on the left side, and if you subtract, remember geometry, it's 132 degrees on the right side. So if we're setting up our n and t, or x1 and y1, moving counterclockwise from x over to have it become normal, that makes a 222 degree angle. That's 132 plus another 90. Now x1 is normal, and 90 degrees from that, so it's tangent to the declining plane, is y1. Again, here's our stress transformation equations. Plugging in all the variables, 2 times theta, 444. We come out to sigma x1, 3.71 ksi, sigma y1, 23.29 ksi, and the shear stress to come out to negative 2.54 ksi. Now, 222 degrees is much more than 90 degrees. Here I have put in our information, and again we have our maximum of 90 degrees. However, if you subtract 90 degrees from 222, that's still 132 degrees. So instead of just subtracting 90, we can move it back 180 degrees. So now x1 is normal on the opposite side of the declining plane, and y1 is tangent with positive leading in the opposite direction on this declining plane. So you can see with the calculations run out here, this ends up having a 42 degree angle, and if we put that in, we can see that the values actually end up the same as last time. The same values exactly. Now you could say this is happening because we've switched sides, but x1 on both of them, they're both still in the same spot, it's just the positive is leading in the opposite direction. However, if you pay attention to your plane stress, we have opposite and equal values on either side, so that it'll sum up to 0. And as such, none of these are going to have a sign change in this problem, and the values still add up to equal each other. So that's another thing that you can do to change where you have put up your axes. There's a lot of leeway where you do it, as long as you stay consistent and pay attention to how you have your sign conventions set up.